Cosine of negative 3 pi over 2, you can just shut it out.
0.
It is 0. What's the sine of 41 pi over 6? It is 1/2. Nice. I assume on the 41 pi over 6 you subtracted 2 pi a few times, and you would have actually subtracted 6 pi away from it, which would have been subtracted.
How many it was away from the next one of 6?
Oh, that's a good way to do it too. Yep. There's multiple ways to do that because you can visualize it. You could do your subtractions. A lot of times you can do the subtraction in your head. All right? Because you're looking for, 36. All right, well, we got 1/2. Awesome. Questions on the homework? Oh, real quick. On the homework, in the book, the answer key said 37 was, I believe it said it's positive, or no, it said it was
I knew it.
positive and it should have been negative.
It was like 636.692. I'm not right on that.
But they had the wrong sign in front of it, right?
Yeah.
They had the wrong sign. And it makes sense because this is negative 0.09 degrees, so that would have been in quadrant 4. Tangent is negative in quadrant 4. So you should have known your answer had to be negative. So if it said it was positive, you should be like, no, it's quadrant 4. You're stupid, book. Learn to read. All right, other questions, though? Other questions going once? Other questions going twice? Nick?
45.
45. I was going to do it anyway. If you didn't have any questions, I was going to ask that one. All right, 45. We've gone over ones like this, and we'll go over ones like this again. It's just sometimes it gets a little... We get up on our head and we start thinking about it too much. This is secant squared over 2 times pi over 6, which is secant squared pi over 3. And what's really confusing about this is that square and where they put it. They put it in a weird place, but it doesn't mean you're doing anything different. I can rewrite secant squared pi over 3 and write it as secant pi over 3 and then square it. All right, so all that square says is whatever I get here, I'm going to square it. It's secant, so it deals with cosine, so I'm looking for the cosine of pi over 3. Pi over 3 is our third tick mark. Cosine is 1/2. So if cosine is 1/2 here, that must mean the secant is 2 over 1, which is 2. So this would be 2 squared, which just equals 4. All right, so don't let those squares throw you. Don't let these thetas throw you. Just, at the end of the day, if you're not sure what to do, just do your normal squaring of a number. All right? At the end of the day, just do what you can do, especially on a test. If you're like, there's a square in here, I don't know what to do with it, just square a number at the end. All right? 90% of the time you'll be right. On this type of problem, you'll be 100% correct. Yeah?
Is that 2 squared any related to the thing? Like what happened there? Or is it just...
I said secant pi over 3 equaled 2. So I just replace the secant with 2 and then you square it. That square comes from this square here. You still don't seem happy with that.
Yeah, I'm confused.
Okay, we see the square here, right?
Yeah.
All right, we know where the pi over 3 came from, right? Do you concur that the secant of pi over 3 equals 2? Or is that where your secant is going to be your cosine? So you find your cosine value, and then you do the reciprocal. Yep. So the cosine of pi over 3 is 1/2. And so the secant of pi over 3 must be 2 over 1 or 2. All right, so if this was just the secant of pi over 3, our answer would be 2. But it's secant squared. So whatever value I get out, I have to square it to get my full answer. All right, so if this square was missing, our answer would just be 2. But that square tells me as soon as I find that value, square it, and then you have your final answer. All right, if this was sine cubed, I would have cubed that last answer. Sine to the fourth, I would have did 4 times, or to the 4th power. Does that make more sense now? Okay, because you didn't seem happy at first. You're just like, oh, okay, whatever. All right, other questions? All right, then let's go on. Today we're going to talk about graphing cosecant and secant graphs. If you can right now graph a sine function and a cosine function, you have all of the elements to do cosecant and secant. And that's because since cosecant is the reciprocal function of sine, we're going to actually graph sine first. We're going to graph it first, and we're going to use, because it's going to be kind of like our guide to come over our next thing. So we're not going to do like a big solid line. Use like a dashed line, a very lightly colored in line for sine, or use a completely different color. And I'll have the colored pencils for this test and for anything you want to use it for. So the first thing I'm going to do is I'm going to graph my sine curve, and I'm going to do it in a light color so it doesn't overshadow the other one. So I'll do it in light blue. So a normal sine curve starts at 0, 0. It goes up to 1. It comes back down to 0. Goes to -1. Comes back up here. I'm going to use a dashed light line, so I'm going to double it up. Saying I know this isn't what I'm using, but I'm using it as a guide. There was a couple of questions I would hope people ask on the homework, so I'm going to go to those particular questions. I'm trying to remember which one it was. Let's look at 15. Let's look at homework question 15. How many of us originally put down 0 as our answer? And then how many of us changed it as soon as we realized that it wasn't 0? And how many of us didn't even put 0 or change it? Okay. So 15 says find the cosecant of -pi. Cosecant goes with sine, so I'm looking for the sine of -pi. Well, -pi would just be going pi in the negative direction, so it brings me over here to 180 degrees, or just regular pi. My sine value here is 0. My sine value here is 0. So when you're thinking about this being the reciprocal, sometimes you might think, well, it's 0 also. But picture this. Sine isn't just 0. It is 0 over 1 that makes it equal 0. We just don't write 0 over 1 there. So it's technically 0 over 1. So as soon as I take the reciprocal of that, it becomes 1 over 0. So in fact, number 15 should be undefined. Anytime your sine, cosine, or tangent values are 0, their reciprocals are undefined. So if I get my cosine equaling 0, that means my secant is undefined at 0. If my tangent equals 0, my cotangent is undefined at that same place. All right, that's big to know because your unit circle does not tell you it's 0 over 1. You just have to know that the reciprocal of our zeros are actually going to be undefined. All right, that's huge. I'm pretty much guaranteed that will be a question on a test. That'll give you one of those values that you have to, like sine is 0, so you have to know that the cosecant is undefined there. All right, so let's bring it back to our graph and why that's important. Well, sine is 0 here, it's 0 at pi, and it's 0 at 2 pi. So that means that the cosecant is undefined at those 3 locations. The way to show undefined on a graph is we are going to use vertical asymptotes. So wherever my sine is 0, I'm going to draw a vertical asymptote. Because cosecant is undefined there. And as soon as you have your vertical asymptotes, you are almost done graphing. Do you need to sharpen a pencil?
Yeah,
Go ahead.
that's fine.
Yeah. Good? All right. Notice how these go down here. The reciprocal is going to make them go up instead. So if we look at the top at pi over 2, rather than going down, my reciprocal is going to go up. What? Is that the sound effect it makes? It goes, wah.
Yeah.
And if that's true, then the one on the bottom is going to go, wah. Because that one's going to go down. And that is our cosecant graph. Don't forget this graph continues on and on and on, so you could just continue. I mean, don't draw this because it's going to look, we're going to write stuff over here, so don't draw this.
So they're all separated?
Yes.
Wow.
They do not connect to each other. There is one going up, and there's one going down, and then it'll go up, and then it'll go down, and then it'll go up, and it will go down.
Do they all stay within the vertical asymptotes?
They do stay within the vertical asymptotes. Because anytime you draw a vertical asymptote, whatever's running up next to it is going to get really close to it, but never touch it.
Okay, so the domain is limited
The domain is limited.
as well. No, as well as the range.
The range is limited. And we're going to talk about the range, actually. We're going to talk about the range right now. Because the homework is going to ask for range. And I feel like some of us struggled a little bit on calculating range, so we're going to do that as a class right now. Range is just, you're just worried about your y values. Whenever I say range, you're just worried about your y values. When I say domain, you're worried about the x values. All right, range is y values. Range is asking you, how low does your graph go to how high does it go? Yes?
So was there in between negative infinity?
Close,
Oh wait, negative infinity.
because we do have stopping points.
Negative 1 and then 1.
Yes. Yep. So the first statement was negative infinity to infinity, but we have to tell whoever's reading this graph that there's a gap here, right? So range is lowest to highest. My lowest point, if I put my finger on this graph, the lowest place I can get is negative infinity. So we have negative infinity, and we are going to use a parenthesis. Because we use parenthesis whenever it doesn't fully reach it, and it can't, we don't know where negative infinity ends, so we always use a parenthesis. Then as we come up, I have to tell the reader of this that it's going to stop at negative 1. I stop here. There's a big gap here. So I go from negative infinity, if I hold my finger on it, it stops here. I can't get any higher on that. So we're going to go to negative 1. Here I'm going to use a bracket, because this negative 1 is included. It's a closed dot. It is included. Then we jump up here. And to make that jump, we're going to put a little union sign. We'll put a little U there. And we are going to start at 1. And then the highest point this graph gets is infinity with a parenthesis. So if you said negative infinity to infinity, you'd be wrong just because of this gap here. Yes?
I don't remember what it was exactly, but like, when do you use and when do you use for? Exactly the class.
It's not going to really be with range.
Okay.
You're talking about like inequalities.
Yeah, I guess it must be one thing.
Yeah, you're thinking of inequalities that it could be either or yeah. It's usually inequalities with equal signs. And we'll get to those later on.
Okay, because I remember working with graphs and then you had to remember whether it was and or.
Yeah, those were systems of inequalities when you'd have like 3 is less than x is less than or equal to 4. But if your signs are facing the other way, it becomes... Anyway.
Oh, yeah.
We'll get to that. We'll get to that. We'll get to that. I know what you're talking about. We'll get to that. Completely sidetracking, but we're good. We're good. All right. Then it says list all of your asymptotes. I do not want to write down every single asymptote because there's an infinite number of asymptotes. You can't just pick these 3 because there's this one, and this one.
Do it.
Oh, just pick that one. We're just going to name that one. No, we're going to actually name them all. We're going to name every one of them. No, it's going to go really, really quick. Because we're going to say I have an asymptote at pi. I have an asymptote at 2 pi, at 3 pi, 4 pi, at 0 pi, at negative 1 pi, at negative 2 pi.
Pi.
almost.
Negative,
we're gonna
positive
use-
negative x times pi.
We're just going to use k.
Oh, okay.
K times pi. Okay. We're going to use k because with math, k is generally automatically an integer. All right, so we don't have to spend the whole time defining it as an integer or anything. K is usually assumed to be an integer. Yeah.
But you have to do like x equals k pi.
You could. We're just going to stick with k pi.
Okay.
Okay. If you want to be super official, we can do x equals k pi, but I'm not worried about being that official right now. I just want us to get in the habit of coming up with these. So super official, x equals k pi. I'm happy if you just realize k pi right now. All right, our next one is not cosecant. We need to cross out that co. That did not get crossed out or deleted in my file because we're actually doing secant. Secant is reciprocal of cosine, so we're just going to graph cosine. We're going to graph cosine and do the exact same thing. Yes?
Do we not care about the domain for this?
No, I'm not worried about that right now. We'll slowly build up to it. We're going to do a whole unit on just graphs. All right, later on. That's when we'll really care about domain, range, and stuff. Right now I care more, can you graph these? Do you understand trig? And then we'll expand to just graphs. Otherwise this unit's going to take forever. Yeah.
Cross out this co.
Cross out the co and leave the secant. Or secant, if you will. All right. Then all we're going to do is graph our cosine, which usually starts at 0, 1. So we'll make it start at 0, 1. It goes down to pi half 0. Then at pi it's negative 1. At 3 pi over 2 it's 0. And finally at 2 pi it is the big uno. I'm going to dash it as well as make it light colored. Just like sine, anytime cosine is 0, its reciprocal is also undefined. So we're going to find anywhere that it's 0, and we're going to put a vertical asymptote there. I'm in fact going to do one more vertical asymptote. So we count that they're 2 units apart. So we count 2 units, so I'll have a third one there. So I did that for a particular reason. A lot of times when people do the cosine graph, they draw this one, then they draw the one going down, then they draw this one. So they make it look like that. I'm not a huge fan of that.
It looks like a sad face.
It does kind of look like a sad face. So I try to, and feel free to do with that, I like to just draw this left one and this bottom one. All right, I leave it look just like sine, just shift it over. All right. However you want to do it, that's fine. It's just a lot of times when people start at this, they do the lower one, and then they completely forget about this one. I do need a full U, and I need a full upside down U, whether it's half on both sides, or it's just the full U right there. I need a full U and a full upside down U. But that is my secant graph. The range is going to be the exact same. The only thing that would change is it would be the domain if we worried about it, but we're not going to right now. So that's negative infinity to negative 1. And we're going to union that with 1 to infinity. Our asymptotes are going to change a little bit. They're going to change a little bit. Notice that we have pi over 2. We have an asymptote at pi over 2. Then we have one at 3 pi over 2.
So it's between the whole number, the whole pi. It's a half a pi.
Kind of. So your initial thought might be k times pi over 2. That might be your initial thought. But that can't work for a few reasons. If you did k times pi over 2, so let's just say, because it's kind of the natural instinct to go, well, it's k times pi over 2 because the first one is at pi over 2. So it only works for one of them. So if my k is 1, then it's pi over 2, that works. If my k is 2, that means my next asymptote is at 2 times pi over 2, which is pi.
That's wrong.
And you keep, right, it ain't right. So what we need to do is recognize that these asymptotes look just like the ones with sign, just shifted over. So the distance between this asymptote and this asymptote is pi units. All right, from here to here is pi units. So we're just going to do k times pi.
So we just have to know. Very much.
Know what? You can figure it out. I can figure out the distance between here and here is pi.
Are we gonna have different periods for these?
Yeah. But the distance between here and here is pi. All right, the distance between here and here is pi. But 1 pi would be here, so I have to shift it either left pi over 2 or right pi over 2. So this can be either plus or minus pi over 2. I'm going to just leave it as plus pi over 2. Yeah.
So does it, like, can you set your first vertical asymptote at your first point on the x-axis, and then from that one point you do pi this way and pi that way?
If you know that this distance is pi. If the period changes, it might not be pi. You might have you might actually have a vertical asymptote here if we condense it down. So your best bet is to graph it and then go from there to figure out your asymptotes. Okay. So your overall steps are graphing. Graph either sine or cosine, draw your asymptotes, and then use the bumps to tell you which way to go. So if you know how to graph sine and cosine, you know how to graph these. And that's what we're going to do in these two examples. So our first one says cosecant of 2 times x plus pi over 2. Recall that period is going to be 2 pi over whatever that b value is. In this case it's 2, so it would be 2 pi over 2, which equals pi. My period is pi. So we're going to treat this like any other problem where I count out 4 units, 1, 2, 3, 4 units, and do a pi there. Then we do half, half, multiply by 3. Half would be pi over 2. Half of pi over 2 is pi over 4. 3 times pi over 4 is 3 pi's over 4. I'm also going to label my y-axis. I'm going to label it a little different than how we have the lines here. That's why I want to do it right now. I'm going to go 1, 2. So I skipped a line just to make this graph a little more zoomed in. -2. Oh, that should be -1. I also want to change this to a negative sign. All right, change this to a negative sign. Otherwise, we have to change a whole bunch of values on this graph. It's just going to be easier just to change it to a negative sign. So we're going to make it x minus pi over 2 instead of x plus pi over 2. Just for the sake of where the graph is zoomed in. Because otherwise I'd be moving it left pi over 2, which would actually mean I'd need to move this axis. And it's hard when it's already a hard axis. And I don't feel like writing stuff off here or changing all my values so I can squish it in here. So just to make your notes look better, we're going to change this to a negative so you can see it a little better. All right, so that means it's going to shift it right pi over 2. More of our asymptotes after we graph it. All right. So we're going to go ahead and graph, since this is cosecant, we're going to graph our sine curve first. But I'm going to graph my sine curve shifted right pi over 2. So normally speaking, our sine curve starts at 0, 0. But I'm going to shift it over pi over 2 units. And that's going to be my new starting off point. And sine goes up first, comes back down to 0, goes down to -1. All right, so then we got to go down to -1, back up to 0, and that is our sine curve shifted over pi over 2 units. Now anytime that sine is 0, we're going to draw vertical asymptotes. because wherever sine is 0, our cosecant must be undefined. Then we're going to go to the top of the bump and go up. Then we'll go to that bottom bump and go down. And we just graphed the cosecant function. Now, if you make it obviously really thick like that, I know I know what your answer is, right? But if you have any kind of ambiguity, you have like stuff that looks all the same, you might want to just put a little symbol to me, say this is my cosecant graph. All right, this one's a little different. My first asymptote is at pi over 2. Then it's at pi, which is actually 2 pi over 2s. Then it's at 3 pi over 2s. Then it's at 4 pi over 2. Then it's at 6 pi's over 2. So this one does work to just do k times pi over 2. But you can rewrite that as k times pi over 2. I don't care. Either way is fine with me. All right, any questions on that one? Okay, our next one is we have secant. Secant is the reciprocal of cosine, so we're going to be graphing the cosine function. I do notice my amplitude is different, so I might note to myself my amplitude is 2. And why I note my amplitude is 2, because I always graph my amplitude first, and then I graph my shifts. If you want to graph your amplitude and your shifts all at once, and you can do it successfully, by all means do it. But I'm just going to graph my amplitude first and then the shifts. Before I do, I have to get my period. My period is 2 pi, because our b value is 1. We're going to shift right pi units, and up, down, down. We're not going up, we're going down 1 unit. Since my period is 2 pi, we're going to count out 4. 1, 2, 3, 4. Put 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. 3 times pi over 2 is 3 pi over 2. Half, half multiplied by 3 works every time. I am going to label these the normal 1, 2, 3, 4. So nothing weird on the y-axis. But I'm going to make sure to label it so I don't forget it and lose a half point. And like I said, what I'm going to do is I'm going to graph cosine. I'm going to graph the amplitude first of cosine, and then I'll do the shifts secondly. So I'm just going to handle the amplitude. Well, cosine usually starts at 0, 1. But since the amplitude is 2, I'm going to put it at 0, 2. Then it comes down to 0. Then it goes to negative 2, back up to 0, and then back up to a positive 2. All right, the next thing I'm going to do is do those shifts. So it says I need to go right pi units and down 1. So on that very starting off point, I'm going to go right pi units and down 1. Maybe I'll draw arrows up here. So that's right and down. And that gives me that point. I'm going to do the same thing to each one. So right and then down. Right and then down on that bottom point. The one that's at 3 pi over 2 goes right and then down. And finally that last point goes right and then down. Alright, so I took care of the period, took care of the amplitude, I took care of the shifts. Now all I have to do is overlay my secant graph on top of it. Now I understand that these aren't at 0, but they really are. These are really still at 0 because the sinusoidal axis shifts down with it. So even though they're not on the x-axis, these are still our 0 values. So we're still going to do our vertical asymptotes through those middle points. Alright, so my vertical asymptotes are still going to go through those middle purple points. All right, then if I go up on that one, go down there, and I go up on that one. Now remember, I said I don't usually like drawing it like this, so what I would have done is I would have drawn one more vertical asymptote, because our asymptotes are exactly this distance apart. So I'm just going to draw one here. And that's going to go up there. Or if you look at, these are exactly pi units apart. The distance between here and here are pi units apart. So I'm going to want that k times pi. But I can't use regular k times pi because I would put it at 0 and here, so I have to shift it right pi over 2. So it's k times pi plus pi over 2.
And for this one, it shifts. Positive shifts to the right, the other actually to the left. Like, unlike.
I'm sorry.
No, no, no.
It does shift to the right, yeah.
Yeah, I was confused.
Oh.
It's like in the between parentheses, it does the opposite.
Oh, gotcha. Could you use subtraction? Is that what you're asking?
No. It's,
Are we talking about this one?
it's like unnecessary.
Oh, okay, okay. If you think of it later on, we'll talk about it. Okay, we need to figure out an equation based upon stuff that's given to me. So I'm going to give you the amplitude, the period, the phase shift, and vertical shift. All right. The other one that you should have to do work on is coming up with your B value. Everything else given to you. Amplitude is 3, so 3 is going to go in your phase shift is pi over 4 to the right, so you're going to have x minus pi over 4. Vertical shift down 3, so it's going to go down 3, so you have a minus 3 at the end. The other one you have to work for is your period. So whenever I get a problem like this, I always circle the hardest one, and that's going to be that one. We have two ways that we can find our B value. We can either use the fact that period equals 2 pi over b. That's one of the things. And that's one we've been using so far. So I can say pi over 2 must equal our 2 pi over b. Or I can shortcut it and realize that these can just swap places. And I can go right to the fact that b equals 2 pi divided by whatever period is given to me. So I can jump right to the fact that b equals 2 pi divided the period, which is pi over 2. I'm going to use this method. It's a little quicker because it's already b equals. 2 pi divided by pi over 2. If I do keep, change, flip, it would be 2 pi times 2 over pi. My pi's would cancel out, and I'd come up with b equals 4. All right, maybe I'll show that math really quick. So I have 2 pi times 2 over pi. Pi's cancel out, I just have 4. So b equals 4. Now I have all my values. My amplitude is 3, so we're going to have y equals 3 times sine. My b value is 4, so we put 4 next. Then we have x minus or plus, depending on which way we're going. We are going right, so that's going to be minus. Pi over 4 is what they gave me. And then it said it went down 3, so we're going to subtract 3. What I want you to do is I want you to do the next one. I want you to do the next one on your own. So right before the end of class, I'll just put up the answer. All right, your answer for this one should have been 2 times cosine of 2 times x minus pi. Is it the cosine that threw you?
Yeah, I wrote down.
Oh, okay, yeah. Make sure you read it carefully because on the test, you'd probably lose half a point, not too much. It was just, the be careful half a point off.